Then you draw a line here. This symbol, the pronunciation is mo. It's a Greek word. Sorry, Greek alphabet. That is the pronunciation, mo. However, in statistics, anytime you see this, that means that you are dealing with population. That's the first impression. I am dealing with what? Population. What does it now represent? It represents population mean. This represents population mean. The other one, you write O like this, then you just extend this hand out. This is also a Greek alphabet called sigma. This is a small letter sigma. The capital letter is our summation. This is also sigma. I hope you are following. Yes. Me, I have no choice but to know. Yes. Question. Yes. Yes. DE. So THE. THE. That summarizes the population. Yes. The one down is capital sigma. The one up is small sigma. Do you get it? So that I'll be telling you the source is the Greek alphabet, the two of them, and what we use them for. As far as statistics is concerned, cancel this one for now. I'm not interested in this. This is population standard deviation. Population standard deviation. So anytime you see this, know that you are dealing with population. Mo, population mean, sigma, population standard deviation. Let's now move to statistic. Statistic. I will not define it. You really want to do that. It has same definition with population. You only change population to sample. Where I do it? How will you put it? Like statistic has the same definition with parameter. How we are following? Only at your definition, you turn population to what? Sample. Now define it. It's a numerical value that summarizes what? Sample. Summarizes sample. It summarizes sample. Example. Otherwise, do you say ah? Example.
It's what?
Okay, we have about yes. Someone called me now. Okay. Before I continue with statistic, let me put 2 here. If you put 2 here, it becomes population variance. So that I'll give as many examples as possible. There was a year in DLI, question number 1, 20 statistical term defined, 1 mark. Definition, 1 mark. Some you have to just provide example. And the moment you are unable to define, you are unable to give example, it becomes 0. I remember very well Professor Riokavo taught us part of this course. Question number 1, 20 definition 10 mark and half. You just chop those marks. And with Dr. Obaka and Dr. Karawak, you cannot run away from definition. Take note. That's their style. Question 1, basically the definition. Then question 2, 3. How many minutes is this course? 2. You have 5 questions, answer 3. Oh, you are in 211. That's objective. And why am I teaching you this way? I should teach you in objective form now. Hey, it's still objective form. It's still objective form. This symbol can be given. Now, what does it stand for? My phone, what happened to it? Okay. Someone is calling. Sorry. Hello. Yeah, wow. I was see very system in Ghana. 301. Okay? Can I proceed? So we have defined statistic. Example of statistic. X bar. What does it represent? It is not mean.
Sample mean.
Sample mean, thank you. You must qualify that mean. Because this also is what? Is a mean. Why this is population mean, this what? Is a sample mean. Another one is S. What does this one stand for? Standard deviation. Sample standard deviation. How about S raised to power 2? Sample variance. Please, you must put the adjective. The question will give you which of the following is not a statistic. How I wish I'm the one that taught this course. Which of the following is not a sample, sorry, is not a statistic? A, B, C, D. Which one is not a statistic? A is not statistic. What is A? Like J, what is A? Check your notes. Hold it out. Thank you, Mr. Kamal. Thank you. Hello. Follow the question, though.
Parameter.
I said that which of the following is not a statistic? Isn't it? We all agree it is A. If A is not statistic, what is A? It's going to be a parameter. I did not say that. Tell me
What
the
is
definition of. I don't know what I understand. You must understand question, though. The way we say question, you may see 2 correct answers, but one is the most correct. Yes, the mean population is correct, but in this context, that's not the correct answer. Because the question says, pick the one that is not statistic. If it is not statistic, it must be a parameter. Let me continue. Read the remaining one up. All this definition, I don't just understand. Source of data, you explain, you read them up so that I can take do we all have this textbook? No. How many of you have it here now? Raise it, let me see. Not many. Okay. Let us do it this way. It is not compulsory, DLR must not know that you write a book. I'm just telling you. The lecturer in question will be sanction, seriously. It's against DLI rule. Even it is against university rule also. If I have textbook, I cannot sell it to you directly. I put it in bookshop, you go there to get it. That is the rule in university. But I must save the neck of my colleague. Yes, I will do that. So next class, we want to answer question on page 1.7. So those of us that have Facebook, we pair ourselves. So question 1 to 10 on page 9, we are going to look at those questions. Now, take for instance, let me take question number 4. Exercise 1.7, page 9. Let me take that one. You can easily answer it. Let me read out. An attempt to enumerate the whole population is called dash. What is the answer? An attempt to enumerate the entire population. Sensor. Enumeration, count, list, highlight. Now, the weights. That means that the textbook has discussed continuous and discrete data. Where? I didn't see it here. Oh, it's here. Let me define the two of them. Let me go to the definition because that's what question number 3 is asking. Sorry, number 2 is asking for. Let's take discrete variable. Discrete variable. What does it mean by discrete? Literally. Secret again. Discrete. No, not the discrete we're talking about. Let me spread the discrete here. I know. DISCRETE is different from that secret we are talking about. You are correct, honestly. So this one, what does it mean by discrete?
Presented in frequency tables.
Whole number. Is this with concrete? How carefully? Is this what? Concrete. It has no relation with time. You can actually determine its definite value. How carefully? The moment you cannot determine the definite value, it is no longer discrete but continuous. I will define. Don't define it. I just want to explain. Discrete is concrete in nature, and we can actually get the definite value, numeric value. For instance, the chairs in this classroom, they are discrete data. We can determine the numeric value, isn't it? I hope that there's nobody here seated that knows his or her age. Do you know your age? I don't know mine. Thank you. If I ask you now, what is your age, and you give me 30, I'll pause. When it is 5 o'clock, I will ask you again, what is your age? You must tell me 30 again. But is it true? No. Because time has passed. You are not here with me. Time has passed. You can't be 30 yesterday and be 30. It's not possible. Time has passed. When you take your child to hospital, look at the way they record it. They will tell you the day, the time, the seconds. They will write all of them. That's the way they will represent it. Not just how old is he, 10 days, they will look at the time. If the child is 1 month, some days, they will put 1 month, 2 days. 1 month, 10 days. Because that's almost the actual age. It is not still the real age. If I must tell mine, as of last birthday, I was 42 years. Me too, as of last birthday, I was. And that's why, if you check my CV, if I want to write age, I put my date of birth. And if they compare me, I always put it as of last birthday. I'll put the last age. My last birthday this. I cannot tell you the current age now until I get to that same date. That's where I can tell you how old. Yes. That 42 years, 8 months, and some days. You can put that. I hope you understand. So anything that has relation with time, they are continuous. Another example for continuous: weight, height. Nobody knows this or height. And as a matter of fact, there is no time in the world that is correct. You want to contest it? Okay. Tune into any TV or radio station. In our station, that's the first class. It is 10 o'clock. They are telling you that elsewhere, it might be 10:01. It might be 9:59 because the seconds are not the same. That's what changes the time. The seconds. If you like, Almighty God will bless my mathematics teacher. The day he taught us this thing, he asked us to put 3 wristwatches. Then we check the seconds. We see that those seconds are never the same. He told us categorically that one of them will get to 12 before the other. There is no time that is correct. In fact, that day, I was necessary that it made us realize that is the reason why in the field of play, any sport that has to do with time, stopwatch has to be. You cannot use the regular, you will make mistake. You use stopwatch. So the time you want to use is 30 minutes. You start. The stopwatch starts till the moment you get to 30 minutes, you pause. And that ends the game. Again, anything that has relation with time is continuous. The one that we can determine the numeric value is concrete. Definite value can be ascribed to it is discrete. Here now, we are all discrete because I can determine the number of students in this class. It becomes what? Discrete. The number of fans in this class becomes what? Discrete. The number of buildings in University of Lagos, discrete. You are not here. The number of houses in our streets, discrete. The number of streets in Lagos mainland, we can actually count. The number of what? Number of rice in what? In a liter of rice. Is it discrete or continuous? Is discrete or if you have it count, counts. Only that it takes time. Let me now let me define discrete variable. This is a numerical variable. This is a numerical variable. Yes, this is a numerical variable that assumes a finite number. That assumes a finite number or a countable infinite number. I want you to underline a countable infinite number so that I explain. In fact, I love that definition. It can assume what? Finite number or a what? Countable infinite number. Is it infinite? Anyhow, me, I don't know. Infinite, infinite, I'm not an Englishman. Now, what does it mean by countable infinite? I hope I'm not too slow. And I'm not too fast. The direct entry, the regular, the known. In this situation, you cannot compare me with any lecturer because some useless students at regular, I taught them tutorial with a particular course. They now had argument with the lecturer in the classroom. They said that's not how Dr. Kamil said it. I'm telling you but because the fellow happened to be a senior colleague and a friend, he realized that I have taught the tutorial of that concept. He called me that thank you, this, but don't divulge too many information. Don't really allow me to teach. I said, okay. What I'm doing now is I won't teach ahead of the class again. I will be behind. So the lecturer will have taught the topic before I go to the tutorial. That's how. So you don't compare us. We have different techniques of teaching, of lecturing, and we have different background. One thing I know that I know to do, I know how to teach. Whenever people tell me, sir, I know how to teach, it's never a compliment. Yes, it's never a compliment. I know how to teach. It's going to be a compliment if I take your economics or financial accounting now, and I'm still teaching. Even if you not even compliment me, I will ask for them. I will ask you that you need to. So, what I'm trying to say this is that the way I am approaching it will be different from the way the lecturers approach it. We are saying the same thing in different languages. Take note of that. Countable infinite number. Let me explain. And that will take me back to primary 1. For my generation, primary 1. For Sorosoke generation, nursery 1 or kindergarten 1. Yes, now we know ourselves. I carry slate from my papa's house, go school. Raise your hand. Slate. I carry slate from my papa's house with chalk. Go to school. Raise your hand. I'll raise my hand. I carry slaves from my own papa's house to school. That's our own generation. Yeah, yes, that's our own generation. I did not even see slaves like this. I don't know what they call slaves. Yeah, that's our second generation. You will not understand slaves. Yeah, that's what we put it here. what? First number, not alphabet. Number 1, followed by. Now, fast forward to this moment.
0.
I have not asked my question now. You have answered from probably now. We have gone back to that stage. I want to explain countable infinite number. We started with 1, 2, 3, 4. Fast forward to this stage. Have we concluded counting that number? No. We have not concluded. Those numbers are what we refer to as countable infinite number. We actually know where it starts. It starts with what? 1, 2. So that number, the set is called natural number. And every natural number is a countable number. We know the starting point, but we don't know. And then, because we don't know the end, that makes it infinite. That we can ascribe it as 1, 2, 3, 4, 5. Make it what? Countable. That's what we refer to as countable infinite number. Can I proceed? Yes. What? Rice, yeah, it can be countable infinite number. It can. Now, example. You can provide the example. I have given series of examples. Books in a library can be counted, am I right? Number of students in a class, number of houses in university, number of buildings in the University of Lagos, houses in a particular locality, streets in a particular local government, number of farms in a class, think, number of what? Let us continue this. Continuous. Continuous variable. This is a numerical value. Sorry, numerical variable. Continuous now. Continuous. Continuous variable. This is a numerical variable that can assume infinite number of values. She put something here, I will put it also. But to me, we can stop at an infinite number of what? Values. She now continue, associated with the numbers on a line no, don't write it. I will explain it. Don't write it. An infinite number of what? Values. Full stop. Example. Age. Before example. Usually, right? Usually, continuous variables is associated with time. Example, age, weight, height, yes. Can you give me example? Time itself, yes. Yes. What? Size. Can we say size? What? That one is still weight. Complexion. No. Now, outside what I just mentioned now. Hello, please take note of the last year. Apart from this example I've given, anytime you see inequality sign used in statistics, the variable you are dealing with is continuous. Anytime you see what? Inequality sign greater than, less than used in statistics, the variable you are working with is a continuous variable. Please take note of that. Yes. Yes, now that's where we have less than. How can I follow you? That's, in fact, for uniform men, whether paramilitary or military, anytime they advertise, they always use inequality. The person should not be less than this height. It's an inequality. You can be more than that. The person should not be more than this weight. I hope you are following. Yes, they always use the inequality. And the variable they are playing with there is continuous variable. Please do. Yes. Sleep. Sleeping. It has to do with time. And it is interval. Then I will take it as continuous. I will take it as continuous. Yes. Now, let's take question number 2 here. The weights of apples harvested by a farmer are dash data. What type of data is that? Continuous. Why is it continuous? Why is it continuous? What is the key word in that question? Wait. However, if I came to the same question, that the number of apples harvested by farmer is dash data. It's going to be this because we can identify, we can actually count the